6.4 polar equations. Okay, so polar coordinates. You know how so far we've learned about Cartesian coordinate planes in all the math classes you've ever taken, where you graph a point because you have an x and a y value and go left or right x and up or down y, right? So that's a Cartesian coordinate plane. Today we're going to learn about polar equations, polar coordinates, etc. Okay, so let's start with polar coordinates. Instead of graphing a point x and a point y on a rectangular like a point xy on a rectangular graph, we use coordinates r theta on a polar graph. Okay, what do you think r stands for? Radius. R is for radius. And what does theta stand for? The angle. And we always start at the positive x-axis and go counterclockwise if it's positive and clockwise if it's negative. So it's just the same stuff we've been doing all year. Same positioning of angles, same positioning of radiuses. Nothing's changed. This is just an application that can be used with the trig stuff we've been learning. Okay, so if this was a polar graph, instead of calling the origin, we now are going to call it the pole. And instead of calling the positive x-axis the positive x-axis, we are going to call it the polar axis. Okay? So then if we want to graph a point, let's do some examples. Let's suppose we have a point at -2 pi-4ths. How would that point be graphed? Now I started out with a negative radius, which seems a little weird, right? So we have to talk about what that means. Now normally when I'm graphing xy, I do the x value first and then I do the y value because that's how they're written and I read from left to right. But I find it easier when I'm graphing polar coordinates to actually do the angle first and then the radius. That's what I recommend. Even though they're written in the order radius, angle, usually when I'm actually graphing them I deal with the angle first and then the radius. Okay, so the angle first then is a pi-4ths. I gave you some graph paper so you could do these on the graph paper if you want, or you can just freehand sketch them on your own paper. Either way, I'm just going to use this. If you're using the graph paper, let me just tell you that the lines, I believe, are 15-degree increments. 15, 30, 45, 60, 75, 90, right? So on these graph grids I've given you, the angles are drawn in 15-degree increments. So, okay. So pi-4ths, of course, is a 45-degree angle, which would be here. So I'm going around pi-4ths. But then what do you think a -2 in radius would mean? That means you're going the opposite direction, yes. So just like if you have a negative x value or a negative y value, you would go the opposite direction. You know, positive x we go right. The negative x we would go 180 degrees the other direction to the left. Or y would be up if it's positive, or 180 degrees in the other direction down, correct? This number acts the same way. So if we've rotated pi-4ths to 45 degrees, but we have to do a -2 radius, that means we're actually going to go backwards 180 degrees from pi-4ths, and our point would be right there. So that's the point right there that we're graphing. So it doesn't matter if you draw the little arc that shows that you got to it, or if you highlight the angle you got to. The important thing is that you know where that point is. And there it is at -2 pi-4ths. Okay, let's try another one. Let's try the point 2, 5 pi-4ths. Okay, so again, I like to usually start with the angle and then do the radius. So the angle 5 pi-4ths is in which quadrant? Third quadrant, because it's bigger than pi, right? So it's going to go, there's 1, 2, 3, 4, 5 pi-4ths. And then the radius this time is a +2 radius. So when it's a positive radius, you go in the direction of that angle. Oh my goodness, what did I do? I gave you a different coordinate for the same exact point. How many different coordinates can match up to any point on a polar graph? Infinitely many. Yeah. Can anyone think of another possibility? Give me another way to do that same point. Can anyone think of something else we could do? So far, we've only done positive angles going counterclockwise. What else could we do to do the same point? Perfect. We could do a radius of 2, but an angle of -3 pi-4ths, which causes us to go backwards 3 pi-4ths, and then toward that angle a distance of 2, thus giving us exactly the same point with a third set of coordinates. So we got exactly the same point with 3 different sets of coordinates. But like we just said, there are infinitely many possibilities. Do you want to practice graphing some on your own before we learn the next thing? I have a bunch. I can give you some to practice. Do you want to just practice for a minute? I think it wouldn't be a bad idea. So let me give you some. You've got some graph paper. Just go ahead and practice graphing. So let me do some different radiuses, different angles. There, I said I was going to give you a different radius, but it's the same again. So here's just a bunch to practice. I'm just going to write down a bunch and then you can practice them. Just quickly, practicing could just mean I'm going through it without writing it down. Practicing could mean actually putting them on the graph paper I gave you. I gave you 2 pieces so you could use one for your assignment and one for your notes. If you need more than that, I've got plenty. Okay, so there's a bunch of points to just practice graphing.